Number 7, we're going to prove this given identity. 2 times the sine squared of theta cosine squared theta plus cosine to the 4th power of theta equals 1 minus sine to the 4th power of theta. So focusing on this side, looking at this, I can see that we have cosine squared and cosine here, so we can factor out cosine squared on both terms. Cosine squared theta will leave us with 2 sine squared theta plus cosine squared theta so doing this part, we get this, and we could almost use the trig identity, but because of this 2 here, that's causing the problem. So looking at where we need to go, we need sine squared. So we can rewrite cosine squared with this trig identity. This is equal to 1 minus sine squared. So we're going to replace this with that trig identity. So we have cosine squared theta, and then we have 2 sine squared theta, and then we're going to do plus, and we're going to replace this 1 minus sine squared theta. Alright, doing that, we have 2 sine squared minus 1 sine squared. These will reduce, so I have sine squared plus 1. Alright, so I have cosine squared theta times, when I simplify this, I'll get sine squared theta plus 1. And then I will also rewrite this one with the Pythagorean identity of 1 minus sine squared. Minus sine squared theta, and I'm going to rearrange this, so this is going to be 1 plus sine squared theta. So when you rewrite these, now it looks like the difference of squares formula. So when I FOIL these out or do the shortcut, this becomes 1, and you square this term, so it's already squared. You just multiply 2 times 2 and get 4, so we get sine to the 4th power of theta, and that matches what we wanted it to equal to on the other side.